All right, we're going to revisit a problem, which was number 48, because I kept screaming about parallel lines and stuff, and I made a mistake when I went ahead and found the ratio opposite the bigger side, and you should always find the ratio opposite the smaller side first. Focus. Okay, so what I did was I went to sine 11 over 10137, and then I did it sine B over 150. I should have found it across the smaller side. So what I should have done was I should have said the sine of 11 over 10137 will equal the sine of B opposite the smaller side. Okay, opposite this side instead of this side. That keeps it from being an ambiguous case, which is why I was stuttering all over myself, because I created an ambiguous case. So when I cross multiply, I get 10137 sine B, and then I divide both sides. Good grief. 50 times the sine of 11 over 10137 equals the sine of B, and then I take the arc sine of both sides. So when I do that, I've lost my calculator, I get the arc sine of, oh, well, good to know. Okay, I get the arc sine of 50 sine 11 divided by 10137, and that gives me 5.4000, whatever. Okay, what that means is that this side is 150. Okay, this side we found out was 101. Why can I not write that? 10137. This side is 50. I know this angle is 11, and I just figured out that this angle is 5.4. So if I subtract 180 minus 5.4 minus 11, I find out that this angle is 163.6. So this angle right here, which is where the pilot needs to swing through, is going to be 180 minus that answer, which is 16.4 degrees, which is what we got a while ago. I just found it using an ambiguous case. So we should have found that angle first. Anyway, all right, so I'm going to do number 49 last, just because we have to look up what a solstice is. And I'm also going to find a pen that works. So we did, we have to come back to 49, so we need to do 51. So this is the final exam review, part 10. So we have two things being suspended. I know that this is 60 degrees. I know that this is 45 degrees. And I know that my box, or whatever that's being suspended, is 1,500 kilograms. So I would like to know what my what the forces are on each one. So I'm going to label this as the magnitude of force 1, or we'll just do force 1 and force 2. So recognize that we've got to swing through this whole thing, okay, because we're coming from a positive x-axis. So when I swing through, if this is 60 degrees, this must be 60, which means this must be 120. Okay, so for force 1, I find out that it is the magnitude of force 1 times the cosine of 120 on I plus the sine of 120 on J. Okay, so that's going to represent force 1. I'm going to represent force 2, which if this is 45, that makes this 45. So force 2 is going to be the magnitude of force 2 times the cosine of 45 on I plus the sine of 45 on J. Okay, and we can actually figure these out because these are benchmark angles. So life is going to be a little bit easier by doing that. Force 3 actually is part of this as well. So we find out that coming all the way through from the positive axis, force 3 is stationary, but he is the magnitude of force 3 is going to be 1,500 times the cosine of we whipped through 270 plus the sine of we whipped through 270 on J. Well, the cosine of 270 is 0, and the sine of 270 is -1, which means force 3 we already know is -1500 on J, because this goes to 0. And this is -1, so 1500 times -1J is -1500J. So, going through this mess, what we have is we're going to create a system of equations. So I'm going to distribute this, but I'm going to rename it. And I'm going to say that this is going to be, I don't even care, let's just do A and B. So this is going to be A, and this is going to be B. So instead of the magnitude of force 1, I'm going to call it A. Instead of the magnitude of force 2, I'm going to call it B. So here's force 1 is A, and here's the magnitude of force 2 is B. And that's just going to make life easier so I don't have a bunch of lines everywhere. Okay, so that means I've got A times the cosine of 120 on I plus A times the sine of 120 on J plus B times the cosine of 45 on I plus B, and I'm going to run out of room, times the sine of 45 on J minus 1500 on J must equal 0. So force 1, if it's going to be stationary, plus force 2 plus force 3 must equal 0. So I took force 1 and I distributed the magnitude of force 1 and force 2 and force 3, and they've all got to equal 0. So now I'm going to rewrite. So I'm going to group all of my i's together. So this plus this must equal 0, because all of this together must equal 0. So combining these two and combining these three must give me an answer of 0. So I've got A times the cosine of 120 plus B times the cosine of 45, both on I, plus A sine 120 plus B sine 45 minus 1500, all on J must equal 0. All on J must equal 0. So now what I've got is a system of equations, because these two things added together must be 0. Okay, so we're going to create a system. So what I have is the cosine of 120, referring back to your unit circle, is going to be 60 degrees shy, which means it's 2 pi over 3. So the cosine of 2 pi over 3 is -1/2. So I really should check that because I'm going absolutely insane with all these numbers in my head. All right, so if I'm at 120, the cosine of 120 is -1/2. So this gives me on A -1/2. So this is going to be my I row. Okay, and then I've got the cosine of 45 is √2 over 2. So I have this many A's plus this many B's must be 0. And then the sine of 120 is going to be positive √3 over 2. Sine of 45 is √2 over 2. And then minus 1500, I'm going to add to the other side. So I get equals 1500. And now this is a system. Okay, so if I actually multiply this thing through by -1, that'll be a positive. So I'm going to take -1 times row 1. So that's going to go positive, and that's going to go negative, which means these two cancel. So I know that 1/2 plus √3 over 2 must equal 1500. So now I know to divide both sides by that mess, and I'll know what A is. Okay, so 1500 divided by 0.5 plus √3 over 2 is, and I get A is 1098.076. Okay, so that's what A is. So now I can go back in here and I can substitute and find out what B is. So I'm going to take half of A, so half of 1098.076 minus √2 over 2B will be 0. So I'm going to subtract this from both sides, then divide by negative root 2 over 2. So I find out, hang on, I find out that the magnitude of force 1, which I designated to be A, is 1098,076. Okay, so force 2, which I designated to be B, is, I'm going to subtract this from both sides. So what I have is a negative root 2 over 2 is a negative 1/2, 1098,076. And then B, where's my B? Okay, and then I'm going to divide both sides by a negative root 2 over 2. So that'll reduce there. So I have got times a negative 1/2 times negative 1. There we go. Okay, and then divided by negative root 2 over 2 gives me a force on the magnitude of B is 776,457. So B is 776,457. B is 776,457 pounds. All right. So that being said, what else do we have? We got 52 is a ship. Okay, so 52, give me 2 seconds to get organized. 52 is, hang on, I've lost control. Give me a second. All right, so I have, there we go. I have a ship leaving port at the same time. So one is traveling 23 miles per hour with a bearing of south 60 degrees east. Okay, so here's my port, and he is south 60 degrees east. So he's going this way. So if this is 60, this must be 30. Okay, so that's one boat. He's 23 miles per hour. 23 miles per hour. All right, the other boat is 34 miles per hour bearing south and then 80 degrees west. So this is 80 degrees, which makes this 10 degrees. Okay, and he's traveling at 34 miles per hour. Okay, after 2 hours. So this boat at 23 miles an hour must be going 46 miles away. And this boat at 34 miles an hour must be 68 miles away. Okay, so 2 hours, how far are the ships apart? So I would like to find this right there. And so I can actually find this using the law of cosines. Okay, so I know angle, sorry, I know side, angle, side. So this angle is 140. Okay, so I know that a squared equals b squared plus c squared minus 2bc times the cosine of a. So I want to know what this is, and I know his corresponding angle. So I've got a squared equals 68 squared plus 46 squared, 268, 46 times the cosine of 140. And then I can square root both sides after I make sure I'm in degrees, which I am. So I've got the square root of 68 squared plus 46 squared minus 2 times 68 times 46 times the cosine of 140. And I get they are 107.38 miles apart. 107.38 miles. There were some fast boats. All right, so that is 52. Hang on, I'm ripping through stuff. So I've got 53. We need to do 53. All right, so a loudspeaker diaphragm is, I'm going to go ahead and do the last 3, and then I'll come back for the other one because we're building a sign. Not like an S-I-G-N, but an S-I-N-E. All right, the loudspeaker diaphragm is oscillating in simple harmonic motion described by the equation of D equals A times the sine of omega t with a frequency of 645 hertz. So my frequency is 645 hertz. That says TZ. Sorry, that kind of looks weird. Z. There we go. And a maximum displacement of 2.43. So my displacement is 2.43 millimeters. Okay, I want to find an equation. So I was told frequency. So remember that frequency is the reciprocal of period. Okay? So if my frequency is, then I can find my omega. So my omega is going to be, I know what the frequency is. It'll be easier to do it this way. I've got b over 2 pi is the frequency. Okay, so in this case, omega over 2 pi is the frequency. So I am told that b over 2 pi must be 645. So 2 times 645 gives me 1290. So my omega, or b, is 1290 pi. And the displacement is the same thing as the amplitude. So my maximum displacement is 2.43 times the sine of 1290 pi, because we're keeping it in terms of pi, times t. And that is it. All right, so 54. A batter hits a fly ball 321 feet from home plate to straightaway center. So here's home plate, and he goes 321 feet. Okay. Give me a second. The outfielder catches the ball, then throws it to third base to try and catch a runner tagging on the play. So I know that there's my little man who caught the ball. Okay, he's in dead center. The angle between the path of the ball from home plate to center field and the line from home plate to third base is 45 degrees. So I know that this is 45 degrees. Okay, the distance from home plate to third base is 90 feet. So here's third base, and there's a little man there. Find the distance that the outfielder had to throw the ball to third base. So I know that this is going to be the distance that I am looking for. So we're going to call him y. Okay. So do I have, what do I know? I do know that this is side, angle, side, and I'm trying to find that opposite side. So I know I can use law of cosines. So a equals b squared plus c squared minus 2bc times the cosine of a. So I know that the cosine of a is 45. And so I know that I've got, the square root of both sides. So a equals 90 squared plus 321 squared minus 2 times 90 times 321 times the cosine of 45 degrees will tell us how far that length is. So the square root of 90 squared plus 321 squared minus 2 times 90 times 321 times the cosine of 45 degrees gives me 265.11 feet. So 265.11 feet is how far he has to throw that. So finally, what we have is we're going to find direction angles, and we are going to find the sinusoidal curve. So honestly, we're going to do those last two problems in the last video.